I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We have 20,000 videos for you, all absolutely free, on our YouTube channel. Every day we upload a video on an average. Here is what we are going to discuss now in this particular video. We'll discuss the end behavior of polynomial functions. As usual, I'm going to make it absolutely simple for all of you. We'll consider what is end behavior, which parameters to check for, how to remember, and take up some questions to practice. After going through this video, you will completely understand this concept and you will be in a position to answer any question related to it, just as most of my students can do. Feel free to send an email on the address given to attend my classes. The results are amazing. Here is what Akshit got.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshit Kandivani.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now let's get the basic concepts of end behavior of a polynomial function. As you know, a polynomial can be written as sum of the terms shown here, an x to the power of n plus an minus 1 x to the power of n minus 1, so on, including a constant. The end behavior really depends on the leading term, an x to the power of n. How it depends on this term? Let's look into this. But before that, some of you might like to review what is a leading term, right? Okay. So in a given polynomial equation, what is a leading term? Leading term is the one which has the highest degree. So as you can see, the terms are arranged in increasing order of degrees, starting with the maximum. To begin with, the last one has degree of 0. And then we have written a term with degree of 1, a1 x, x to the power of 1, that is, right? So n is the degree of this polynomial, and here the leading term, let me write down clearly what a leading term is in general, an x to the power of n. Once you identify the leading term, the degree and leading coefficients are obvious. Degree will be n and the leading coefficient will be an. Is that clear to you? To give you an example, here is a function 3x to the power of 5 minus x to the power of 4 plus x squared plus 2x minus 6. So what is the leading term here? Well, the leading term is 3x to the power of 5. And in this case, as you can clearly see, the degree is 5 and the leading coefficient is 3. In the next example, the leading term is minus 2x to the power of 4. So you can see in the second example that the leading coefficient is negative, right? And in the first, the leading coefficient is positive. So we are concerned about this leading coefficient. Here, as you can see, I'll write an. The leading coefficient is 3, which is greater than 0. That means it is positive. Now in this case, the leading coefficient an is minus 2, which is less than 0, or you can say it is negative. Now this value of leading coefficient is of our importance. Not actually the value, but the sign whether it is positive or negative. The other parameter which we are looking into is, of course, the degree. Now, in this particular case, what is the degree? The degree here is 5, correct? Now, 5 means odd degree. Do you see that? Let me write down odd here. And in this case, the degree is 4, which is even degree. So, we'll talk basically about leading coefficient is greater than 0 or positive, or less than 0, negative, or whether the degree is even or odd. That is what is going to decide about the end behavior. Perfect? Okay, so let's continue now. So what is end behavior? End behavior is what happens when x value is very large. When x value is approaching either negative infinity or x value is approaching a positive infinitely large value. So we're checking the value of function, which is f of x, when x is approaching positive or negative infinity. That is what the end behavior is. So on a graph, you can see very clearly that one of these graphs has, as shown here, it is approaching positive infinity when x is approaching negative infinity, and on the other hand also, it is approaching positive infinity. On the other hand, we have something here where when x approaches negative infinity, y approaches negative infinity, and on this side, when x approaches positive infinity, it approaches positive infinity. So we are calling this as opposite ends. You get the idea. We're calling these as the function is going on opposite ends. And in the first case, we are calling these as same ends. So we're saying that if the y value is both sides same, means approaching positive infinity, whether x is approaching negative or positive, we're saying that the graph of the function faces same side. And if it is like an odd function, opposite ends. You get the idea. So end behavior is absolutely clear to you, which is what happens when x is very large. Now, to find the end behavior, we have to look into some parameters. So what are the key parameters to check? As you know, we have to look into the leading term, right? So we have to check two things. One, the leading coefficient an, whether it is positive, that means greater than 0, or an is less than 0. So these are one set of parameters which we have to check, which we'll get right from the equation. And the second is, we'll check about the degree, whether it is odd or it is even, right? That will define the end behavior. Perfect. So now, when parameters are clear and you understand what is end behavior, let us see how are they related. So in this particular screen, we have made a matrix in which the rows indicate when an, the leading coefficient, is positive or when it is negative. So this is for an being positive and this is for an being negative. Is that clear to you? So we'll see how the behavior of the function is at the ends. That is to say, when x is approaching positive infinity or negative infinity. Correct. And in the columns, we have taken the degree. So degree being odd on the left side, degree being even. Correct. So this is where we'll focus on two conditions. That is to say that here we have an, which is positive and the degree is odd, correct? And in this case, we have an, which is negative and the degree is even. So, no, an is positive here also. An is negative in these quadrants. ends, right? So an is negative here, an is negative here, and degree is odd, and in this column it is even. So that is the combination. Is that clear to you? Okay. So let us now first explore what happens when the leading coefficient is positive, right? So when the leading coefficient is positive, in that case, we have seen that all the polynomial curves, they end up in quadrant 1. So they will be actually facing in this fashion, right? So all will end in quadrant 1 if an is positive. Is that clear to you? So that is how it is going to look. However, when the leading coefficient is negative, in that case, the graphs will end up in quadrant 4. So this is when an is negative. Is that clear to you? That is where they're going to end. So you can write here that this shows that when x approaches infinitely large value, then y also approaches infinitely large value in case of an being positive. Is that clear to you? And here you can say that x approaches infinitely large value, then y approaches negative infinitely large value when an is negative. Is that clear to you? So that is how we can see these two rows when an, the leading coefficient, is positive or it is negative. Now, let us explore the part about the degree. Now, what happens when the degree is odd? When the degree is odd, in that case, the graph goes from one end to the other. It goes from opposite ends. Opposite ends means it was going to quadrant 1 from 3, right? So these are the opposite ends. It will go from 3 to 1. You get the idea. So in this case, since it's ended up in quadrant 4, it will go from 2 to 4. You see that opposite end. Do you see that? Kind of. Okay. So that is what happens when we are talking about odd degree polynomials. Now when it is even degree polynomials, in that case we have same ends. So if it is up on the right, it is up on the left. If it is down on the right, down on the left. You see that picture. So that is how the graph are going to be. To give you an example, let us say we have x cubed, right? So if I have x cubed, for example, the graph will be kind of like this. You see that? This is for x cubed. But if I have minus of x cubed, the leading coefficient being negative, then the graph will be kind of like this. You see that? On this side, let's take example of x squared. So if I have x squared, the graph will be like this, right? Both on the same set ends, and minus of x squared will be like this. So it goes from negative infinity to negative infinity. You get the idea. So you could write here that if x approaches negative infinity for odd function, then y approaches positive infinity. But for the even degree function, if x approaches negative infinity, y also approaches negative infinity. Is that clear to you? That is what it is. And this summarizes the behavior. We'll actually explore this more for you to understand. So in this case, we are taking odd degree polynomials, right? So what I will do here, I will sketch the graph. And you need to tell me what should be the leading coefficient for that particular graph, okay? So here is the graph of odd degree polynomial. Odd degree polynomial will be something like this. You see that? So that means we are summarizing odd degree as opposite ends. Right? So you see it is going from quadrant 3 to quadrant 1. That is opposite ends, right? So what should be the leading coefficient? Can you tell me? For this, for the green graph, what is an? An, is it positive or negative? It has to be positive since it is ending up in quadrant 1. Is that clear to you? Let's have another graph here, and let's say we have this graph. Now this particular graph ends in quadrant 4, right? So that means an, the leading coefficient, is less than 0. And since it is opposite end, we know that degree is odd. Does it make sense to you? Perfect. So we've summarized here for you that if the degree is odd and leading coefficient is greater than 0, in that case, when x approaches positive infinity, y approaches positive infinity, but when x approaches negative infinity, y approaches negative infinity. That is to say, opposite ends. Is it okay? Now let's look into the graphs of functions when the leading coefficient could be positive or negative, but it is of even degree polynomial. So we're talking about even degree polynomial. That means the value of n could be what? It could be like 2, 4, 6, 8, and so on. Even degree, right? So in even degree polynomial, same ends. You get the idea. That means the condition could be that if x approaches positive or negative infinity, y approaches the same value. You get the idea. So, only thing which is going to decide where y approaches is whether an is greater than 0 or less than 0. If an is greater than 0, then y approaches positive infinity, period. And for x approaching positive or negative, y approaches negative infinity if an is less than 0. You get the idea, right? So the graphs could be like what? Let me now make a smaller graph since you understand the concept. So if I make a graph like this, it means what? It means it belongs to this category. Is that clear to you? However, if I make a graph which is kind of like this, it means that it belongs to that category where the leading coefficient is less than 0. You're getting it now, right? So I've increased my speed also. You're with me, right? Well, here's the summary. If the leading coefficient is positive, an is greater than 0 for the even degree function, in that case, do you see that? Same ends? Perfect. So now, how to remember this? How to remember it? So there are just basic rules to remember. We are only looking at the leading coefficient, correct? Always look at the leading coefficient. If it is greater than 0, that is to say positive, in that case, y is always approaching infinity. Is that clear to you? Right? And if n is odd, in that case, we have opposite ends. And if n is even, then we have same ends. Perfect. And what happens when an is negative? Well, it reverses, right? So, if an is positive, of course, y approaches infinity. But if an is less than 0, then y approaches negative infinity. So you have to remember this key, right? And the other key. Same ends and opposite ends. That helps. Perfect. So from this graph, we can say that this graph is for even degree, right? And an greater than 0. Does it make sense? Both same ends, right? On the other hand, this particular graph, which I am highlighting now, is odd degree, opposite ends, right? And an is less than 0 because it ends up in quadrant 4. Make sense? So that is how you have to look into it. Now here, I have summarized all these things in points. You can pause the screen and read it out. So you know what a polynomial is. And what is end behavior? To find the value that the function approaches if independent variable approaches a very large negative or positive value. That is what end behavior is. So basically, we have to only figure out what happens when x approaches positive infinity or when x approaches negative infinity. An, the leading term, is the key, and the end behavior of our polynomial function will be something like this. If an is greater than 0, right side up, quadrant 1. You get the idea. If an is less than 0 means negative, right side down. So right side up and right side down is very key to remember. If an is even, same sides. If an is odd, even the degree, then opposite ends. So we're talking about two things, as you can see, leading coefficients and degree. Perfect. So at a glance, here is how it looks, and we have sketched these graphs for positive leading coefficient. We have given the end behavior. We are given the end behavior for positive leading coefficient, and if an is negative, it will be other way. You get the idea. Perfect. Have a good look at it, and then we have some practice questions for you. Correct? So before we get into practice questions, okay, let's go straight. So here's the very first practice question for you. What you need to do is just provide end behavior for the polynomial functions, right? So the very first one is 3x to the power 5 plus x squared minus x plus 5. So identify the leading term, which is that, correct? Degree 5. So what do we notice here? That an is greater than 0 and n is odd because 5 number is odd, correct? So what should be the behavior? The end behavior will be, since it is greater than 0, graph will end up in quadrant 1. Since it is odd, it will be in opposite ends. So you can write this as, when x approaches negative infinity, y approaches negative infinity, and when x approaches positive infinity, y approaches positive infinity. Perfect. The next one here is minus 2x to the power of 11, and this is for you to do, right? So this is for you to practice. So for you. So try it out. Clear? Remember, this is negative. Question number 2, very similar to question number 1, and this time there is a trick. Sometimes when you get the polynomial equations in the test, you will notice that the equations are jumbled up. That means, in question number 2, can you tell me what is the leading term? It is not the first one, but this one. Do you see that? X to the power of 5. So sometimes the leading term may not be at the right position. So you have to be careful while you observe. And now, since this is even, we have seen that here, leading coefficient an is negative, right? Less than 0, and it is even. Since it is even and less than 0, then the graph will be facing downwards. That is the end behavior, which you could write that when x approaches negative infinity, y approaches negative infinity. When x approaches positive infinity, I wanted to write x, y approaches positive infinity. Clear? Next one, identify correctly the leading coefficient and then write down your answer. So try this out, correct? So with every question, I'm giving you a sample answer. The other one is for you to try. Many times, we provide you polynomials in factored form. Now, I'll do one of them. So let me do this time the second one. Now in this case, what is the leading coefficient? Is it positive or negative? You need to multiply all these terms, right? Do you see that? All the x values along with their powers. And what do you notice? Well, it is negative, right? So So we have an, which is less than 0, which is negative. And now it's the term to find out the degree. Add the exponents when you multiply, right? 4 plus 2, 6, 6 plus 1, 7, plus 1, 8. So in this case, it is even, correct? Since it is even, I can easily sketch this graph, which is leading coefficient less than 0 means this side is down, correct? And this is also down, same ends, correct? So that is how you're going to do it, and you can easily write down if x approaches negative infinity, y approaches negative infinity, x approaches positive infinity, y approaches negative infinity. Same side, you see that? Same ends, right? Likewise, you can do the next one also. Absolutely clear for you, so try this out. Now let's move on to the place from where we started. I hope all the concepts are absolutely clear to you. You understand what a polynomial is. And in a polynomial, we are always looking for the leading term to decide about the end behavior. Perfect? So, we have to look for two things. One is what is the degree, and the other, what is the sign of leading coefficient to decide the end behavior. End behavior really means if x approaches negative infinity, y approaches what? And if x approaches positive infinity, y approaches what? And this what, in case of polynomial, is infinitely large value, of course. It could be positive or negative. So I hope the concepts are absolutely clear. Feel free to write your comments and share your views. If you like and subscribe to my videos, that will be great. You can also send an email on the address given to learn and explore and master the topics in mathematics. Thank you and all the best.